Today we're going to be talking about graphing quadratic inequalities, and I'm going to do old school notes kind of on this. And um, um, some of this is going to seem really obvious. Some of it might not. So if you feel like I'm insulting your intelligence, I don't mean to. All right. Step part number one: if the inequality symbol is greater than or less than, the curve is going to be dotted. Dotted, dash, however you want to do it. Um, Generally, what I do, just Mr. Clark's secrets, I'll draw out like a normal graph and then take my eraser and then erase little chunks out of it because I'm not so good at doing arty things like making dash lines. I will not judge you, I promise. So this is a lot like just graphing regular inequalities as far as the how the lines work. Which means if the inequality symbol is greater than or equal to or less than or equal to, the curve will be solid. I can't spell. That is not how you spell the curve. Curve will be solid. That may actually be the hardest part. All right. So what I'm going to give you next is the trick, the specifical trick to this. There are other ways to do this, by the way. This is the way that I do it because I like to not do extra work. So to figure out where to shade, out where to shade, you want to try a point on your coordinate plane that is not on your graph. So I'm going to say try a point that is not on the graph. So what I mean by that, let's say you've got, your parent function, it's x squared. I don't want to pick a point like 0, 0 or 1, 1 or 2, 4. It's on the line. I want to pick some point that is not on the line, that is also not a lot of work for me to do calculations on. So maybe 0, 0, maybe 0, 1, maybe 0, -1, a really simple point. I want to do the least amount of work possible in order to get the right answer. So I normally when I choose a point to work with, I'm going to pick something near the origin just because it means less multiplying and stuff like that. All right, so let's see if I can make a sketch a graph and have it not be totally hideous. So let's do an example. We're going to graph y is greater than negative x squared minus x plus 6. And this is a little bit of a mean problem, but, whatever. So if you remember, and if you don't, because this was right before the ice storm, I don't blame you. We got to figure out what our vertex is. So I'm going to pick my x coordinate first. And the equation for that was the opposite of b over 2a. Let me scooch this down. So in our case, negative b would be positive 1. And then 2a would be 2 times negative 1. So negative 2. So for my vertex so far, I know that my x coordinate is negative 1/2. So next what I'm going to do is I'm going to plug that in to my equation, which I think I may regret really quickly, but whatever. So that means I'm going to have negative 1/2 squared minus negative 1/2 plus 6. That's kind of a bummer. Whew, okay, 1/2 squared is 1/4. The opposite of 1/4 is negative 1/4. The negatives cancel out and make a plus. Make my fractions convenient. 1/2 is 2/4. And then plus, let's see, 6 times 4, 24. 24/4. So 1/4, negative 1/4 plus 2/4 is going to be 1/4. And 1/4 plus 24/4 will be 25/4. Gross. Or 6 1/4, however you want to do it. I'm going to say, so negative 1/2, comma, 25/4 is my vertex. That is a really inconvenient vertex. Of course, it's a math problem. All right, so if I look at that and I factor it, we swap it over to x squared plus x minus 6. That factors to x plus 3, x minus 2. You could have done quadratic formula, but in this case, factoring was faster. So my x-intercepts end up being negative 3 and positive 2. And that should be enough for me to sketch my graph now, which is all I really wanted to do. I'm not going to make this look perfect or fancy or anything. So I'm going to do sketching of graph, making a graph sketch over here, doing stuff and junk, yeah. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, crud. 6, 7. 6. Don't be ugly. Oh no! Yes. All right. Here we go. Told you it wasn't going to be very precise. All right. So our x coordinate is negative 1/2, and our y is 6 and 1/4. So 1/2. 1, 2, 3, 4, 5, 6 and 1/4. So like somewhere in this vicinity. My x-intercepts are negative 3. 1, 2. That's a hideous graph. My gosh. And 2. All right, cool. So what I'm going to do, man, I can't draw it like I normally would. Y'all, this is going to be hideous, and I apologize. Because if I make the parabola and then try to etch out little pieces, I think it's just going to erase the whole parabola. All right. I'll do my best. Don't judge me. Okay. Making a parabola is parabolic. All right. Close enough for government work. So we have this here parabola. It's actually a lot better than I thought it would be. So what I'm going to do, now that I've done this, and by the way, like, if you're not working on paper, just put it in Desmos. I'm just doing this to be really thorough. So what I'm going to do to solve this is I'm going to pick some point that is not on that graph. It looks to me like the easiest point here is 0, 0, right? Because it is not, here it is. It is not actually on the line of the graph. So what I'm going to do is I'm and I'll do it over on the right side. So I'm going to write down 0 is less than negative 0 squared minus 0 plus 6. So the zeros kind of make nothing, right? So I end up with a statement of 0 is greater than 6. Is that true? I've seen some people on Facebook that say this is true. They frighten me. 0 is not greater than 6. This is a false statement. Now, here's the deal. If you pick your point and you get false, you're going to shade wherever that point is not. If you pick a point and it says true, you're going to shade where that point is. So I chose the point 0, 0, and 0, 0 is inside, or it's inside the parabola. I got false, which means that my answers will not be inside the parabola. So what I'm going to be doing is I'm going to be shading outside the parabola. So let's see. Terrible, but I'm going to try. My answers out here are going to be shaded. And I chose kind of a bad place to put this, but I think you get the idea. So, I mean, really, you know how to graph a parabola. I'm not worried about that. We did that for a while. The only thing that's new, it wasn't good noise. The only thing that's new to me is how to determine if you're shading inside or outside. And TBH, like it's not rocket appliances. Come on, I'm not tangled up. Yo, I'm not having a good morning. I'm a hot mess today. All right, so let's do another one. Do another example. How about we try y is greater than or equal to x squared plus 4x minus 5. All right, so my first step is going to be to figure out where my vertex is. Will be negative b over 2a. Will be negative 4 over 2. So my x component, why isn't it showing up? Mr. Clark is sometimes dumb. My x component is going to be negative 2. So all I'm going to do is plop that back into my formula and get negative 2 squared plus 4 times negative 2 minus 5. Let's see. Negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. And minus 5. So we get negative 4 minus 5, so negative 9. Really, negative 9? Why did I pick this problem? That's a bummer. Oh well. So our vertex will be at negative 2, negative 9. Next, I want to find my zeros. Can I factor this? Are there two factors of -5 that make 4? Yes, Mr. Clark. Mr. Clark, I'm pretty sure it's 5 and 1. Very good. Let's see. We factor this. We should get, what is it, x plus 5 minus 1. So our x-intercepts will be x equals -5 and x equals +1. That should be all we need to graph it. Man, I'm going to regret. I really wish I had like a button and I could just click it and a graph would appear so I wouldn't have to sketch out an ugly graph. I feel embarrassed by that. Like I should have a nicer thing for you guys to see. Oh well. Making a graph. Where is this? -2? Oh, we gotta scooch that over more. -9. Let's do it like maybe this. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll say 10 for good measure. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, just for good measure. All right. So vertex at -2, -9. 2, 3, 4, 5, 6, 7, 8, 9, right about somewhere around here. My zeros are x is -5. 1, 2, 3, 4, 5, probably right about there. And 1, probably right about there. All right. Is my line going to be dashed or solid? Mr. Clark, it's going to be solid. Very good. It's going to be solid because of the equal part. I'm feeling joyous. Okay. Yeah, that's terrible. You guys got the idea. All right, we got our graph graphed. Next step, I got to figure out where I'm shading. So I'm looking at my graph and I'm thinking, what's a convenient point? I like 0, 0. Zeros only 0. And my statement says 0 is greater than or equal to -5. This time that's true, which means I'm going to be shading inside the parabola. So I'm going to do my shadings. This time anything inside or on the parabola is going to be a solution to the problem. Whee! Art schools everywhere rejoice that I did not apply. All right. So, the other way to do this, I'm trying to teach you like, the normal way that I'm supposed to teach you, but I'm going to show you the other way too, just because I'm that kind of dude, would be if I had a handy dandy graphing calculator with me. And let's say, I'll do both those examples. My first one, I'm going to do what they would teach you if we had the textbook. Minus x plus 6. So they would tell you to graph the parabola in your graphing calculator. Then they would say, pick the point, test the point, and then on your paper, shade where it goes. Which isn't significantly different than what we did. To be honest, if you're in here, you can legit just do this, and it gives you the answer. I like that. That's a new thing. Doing this in an nspire is slightly more complicated. You have to go in the graph entry and change it from equals. You have to open the menu and select which inequality. It's not a whole lot harder. I would show you on the board, except I don't have access to the software that lets us see the nspire on the board because I actually don't know why. They won't let us install it on district computers. I know that, but I don't think I have a key for my computer. So if you choose to do it by hand, I recommend checking it just for good measure. Let's make sure I didn't muck the other one up. Y is less than or greater than or equal. Oops. Thank you. X squared plus 4x minus 5. So yep, that one worked out pretty well too. Okay, so let me go ahead and close all this.